dear children. Today we will discuss the new chapter. We'll start with the new chapter, current electricity. Now the word current electricity is very common to all of us. This electricity is a form of energy, like the heat, like sound. Okay? Electricity is also regarded as a form of energy. Now why they are considered as a form of energy is they perform work. They do some work. Now what work the electricity they do? They light our house. They run various electrical gadgets. They also used in different places, okay, in industries, in factories, everywhere. Now this electricity, without electricity, is very difficult for us to perform or do any kinds of activities, especially during the night. If there is no electric current, the children, you won't be able to do your work, your activities like studying, doing homework, watching TV. Okay. So if there is no electricity, you won't be able to operate the electrical gadgets like a refrigerator, television, even you won't be able to charge mobile phones and so on. So this electricity is doing some work. Okay, they are lighting our house. They are running, different electrical gadgets. So and so on. So therefore we can say that electricity is a form of energy and it is very useful to all of us. Now without electricity, it's very difficult for all of us to live. Okay, like one day, if there is no current, or even you consider for a week, if there is no electric current, what will happen? Your phone, your mobile phone will totally, it goes down and the battery it goes down and the phone gets switched off. You won't be able to play with the phone. Okay, you browse the internet or play games, and even with the television, if there is no electricity, you won't be able to watch TV and so on. So that means it becomes very boring for all of us. Okay, so therefore, so we are in a stage, we are in a place where without electricity, it is very difficult for all of us to live. So therefore, electricity plays a very important role in our life. Now this electricity, before we come to the term electricity, let us discuss about the term atom first. Okay, now every atom, they are made up of the subatomic particles, electron, proton and neutrons. Now the electron carries negative charge, proton carries positive charge, and the neutrons are electrically neutral. Okay, now electric current, actually it is a flow of electrons in a definite direction. Now how the electrons will flow? Now what type of electrons will flow? Let us discuss that first. Now let us consider the nucleus. Nucleus has what? In the nucleus there is a proton and a neutron. Outside the nucleus, electrons are there which revolve in their respective cells or orbit. Now this circle which I have made, this is the cell or the orbit. Now if I make number of cells or the orbit, okay, with electron revolves, and the electron they revolve in the respective, they remain in the respective path or in the respective cells. Now the electrons which are very closer to the nucleus, they are strongly attracted by the force of attraction. And these electrons, they are not free to move, they will not move their place because of the strong force of attraction of the nucleus, and therefore these electrons are known as the bound electrons. BOU and the bound electron. And the electrons which are present in the last cell, or that means in the outermost cell, okay, these electrons are free to move because these electrons are not strongly attracted by the force of attraction of nucleus. As the electron goes away from the nucleus, the force of attraction of the nucleus, with the electrons will become lesser and lesser. So, when we consider the electron in the outermost shell, the force of attraction is very less or no force of attraction. And therefore, this electron can leave their place. They can leave their place and they can move. Okay, they can move out. And these electrons are known as the free electron or the valence electron. Free electron or the valence electron. So therefore, now this free and the valence electron can move their place and they can they can leave their respective place and they can move to some other place. So therefore, when we consider about this valence electron, the conducting materials, all the conductors, okay, all the metals, conducting materials, that is the metals, they have plenty of valence electrons. And these valence electrons will move from one end of the conductor towards the other end. And this flow of electrons from one terminal of the conductor towards the another terminal in a definite directions will constitute electric current. So therefore we can say that electric current is the flow of electrons in a definite direction. So in a metals, in a conductor, always in a conductor they have got valence electron, and these valence electrons will move from one end of the conductor towards the other end. So this way how the electric current forms. So electric current is actually the flow of electrons. Okay, now the next point. Now after that, let us consider about what determines the flow of electrons. Okay, what determines the flow of electrons? As you know that electrons, they flow from one end of the conductor towards the other end. And how they from where they will flow and where it flows. So let us consider this is a conductor. Okay, this is a negative and positive. And this conductor are connected by a wire. By connecting wire. These are the charged conductor, these are connected by a wire. Okay, now the electrons will flow from negative to positive. Okay, electrons will flow from negative charge conductor towards the positive charge conductor, and the current will flow from positive charge conductor towards the negative charge conductor. Now this flow of electron is determined by a quantity known as potential. Known as potential, or we call it as electric potential. P-O-T-E-N-T-I-A-L, electric potential. Now let us discuss about, I'll give you the two examples here. Okay, now the first example is, let us consider two bodies. Okay, the hotter body and the colder body. One body is hot, another body is cold. Okay, the hotter body has got a higher temperature, colder body has got lower temperature. And if you want to make the flow of heat between the two bodies should be in contact. If you keep the two bodies separately, the heat cannot flow. If you want to make the flow of heat from hotter body towards the colder body, always you have to bring the two bodies in contact. Okay, so when you bring the two bodies in contact, the hotter body, the heat from the hotter body will flow towards the colder body, and the colder body slowly they rise the temperature, and that flow of heat will take place unless and until both the body will attain the same temperature. So that means in order to make the flow of heat, the two bodies should be in contact. Next one, let us consider a two vessel filled with water, and always the water flows from the high level towards the lower level. Okay. Now, if the two vessels are kept separately, the flow of water cannot take place. If you want to make the flow of water between the two vessels are connected, should be connected with each other. So let us consider two vessels, and two vessels are there which are connected with each other. Okay, these are the two vessels which are connected, and here is a stopwatch is there. Yeah. Stop valve is there, stopcock is there. Okay, and if the two vessels has got a same level of water, if the level of water is same in the two vessels, the water cannot flow because the level of the water is equal. Now what you do is that in order to make the flow of water, you have connected the vessel with each other, and in one vessel you fill the water up to the brim. So up to one vessel you fill the water up to the brim here. Another vessel keep it and you keep it same. Now you just open the stopper or the valve. Once you open the valve, now the water will flow from a vessel having more water towards the vessel having less water. So that means the water will flow from the vessel having higher amount of water towards the vessel having lower amount of water. So now this flow of water takes place unless and until both the vessel will have got same level of water. So from this two example, what you understand is that in order to make the flow of water between the two vessels should be in contact. When I keep the two vessels separately, the water cannot flow. When I keep the two body, one hotter body, colder body, separately, the heat cannot flow. Likewise, if you want to make the flow of the electrons as well as the current, the conductor should be connected with a metallic wire. It should be connected with the wire. So once you connect with the wire, now the electrons will flow. And the electrons will flow from the conductor having negative charge towards the conductor having positively charged. Okay, and the conductor having negatively charged have got axis of electrons and they are said to be as a lower potential. I have written LP, that means lower potential. And the conductor having positive charge is considered as a higher potential, XP I have written here. Okay, and the electrons will flow from the conductor having lower potential towards the conductor having higher potential. So that means if the two conductors are not connected with a metallic wire, there will be no flow of electrons. If there is no flow of electrons, there won't be flow of current. So likewise, what I have done is that now the two conductors are connected by a metallic wire. Once you connect with the metallic wire, the electrons will flow from negative terminal towards the positive terminal, and that direction of the flow of electron is determined by a quantity known as potential, or also known as the electric potential. Okay, so therefore now electric potential is the amount of work done. It is defined as the amount of work done. So that means how we can say that electric potential or the potential is the amount of work done, because when there is a flow of electrons, there is a flow of current. Okay, electricity is produced. As we know that electricity is a form of energy as they are doing the work. So therefore potential is defined as the amount of work done in bringing a unit positive charge, okay, from the infinity to the point. Infinity means very far. Okay, bringing the positive charge from infinity to the point, that is known as the potential or electric potential. Okay, so now this potential, it is a scalar quantity. Okay, and it is denoted as capital V. Okay, and the SI unit of potential or electric potential is known as volt. The SI unit is volt. Okay, which can be written symbolically written as V. So now this electric potential. Now how will you find the electric potential is that, so from the definition of electric potential, V equals to work done, okay, divided by charge. Work done divided by charge. From the definition, it is the amount of work done bringing a unit positive charge from the infinity to the point. So what I do is that I write it in V, SI unit of potential V, SI unit of work done is joule, and the SI unit of charge is coulomb. COULOMB, coulomb. Now I write here 1V, 1 joule and 1 C. So therefore, now you can define volt. Now if 1 joule of work, now define volt means how do you define volt? If 1 joule of work is done in bringing 1 coulomb of positive charge from the infinite to the point, it is said to be as 1 volt. Okay, so if 1 joule of work is done in bringing 1 coulomb of positive charge, okay, from infinity to the point, it is known as 1 volt. So therefore potential can be found by using the relation V equals to W upon Q. W is the work done, Q is the charge. Okay, so this is the formula. You just remember that V equals to W divided by Q, and the SI unit of potential or electric potential is volt, okay, and can be written as V. Now the next point, let us come to the next point, that is potential difference. Now the potential difference in an electric system, okay, next one is the potential difference. P-O-T-N-T-I-L, potential, D-I-F-F-E-R-E-N-C-E, potential difference. Now when we talk about the potential difference, now in an electric system, the potential difference between the 2 points, okay, the potential difference between the 2 points means like this. This is negative, positive, okay. The potential difference between the 2 points is more useful than the absolute potential difference at one point, which means that when we talk about the electrical system or in electric system, instead of using the word potential, we use potential difference. Okay, that means in an electric system, the word potential difference is more useful, okay, than the potential at one point, because potential is maintained only at one point. But whereas potential difference is maintained between the 2 points here. Since between the 2 points I am connected with a metallic wire, with a conductor. Okay, and when the potential difference is maintained between the 2 ends, that makes the continuous flow of electric current. Remember that the potential difference between the 2 ends of a conductor maintains the continuous flow of electric current. So when we talk about the electrical system, instead of using the word potential, we use potential difference. Okay, because potential difference is between the 2 points, whereas the potential is only at 1 point. So therefore, the potential difference, we use the word potential difference, and the SI unit of potential difference is also same, that is volt. Okay, and it is also written as V, and the potential difference is also calculated as potential difference V equals to work done divided by charge. Okay, so how you define potential difference is that it is the amount of work done in bringing a unit positive charge from one point to the other. Okay, so that means this potential difference is existing between the 2 points here, whereas potential is existing between one point only. So therefore, in electric system, instead of using the word potential, we use potential difference. Okay, so potential difference can also be defined. That means V equals to the SI unit of work is joule, SI unit of charge is C. Okay, then 1 joule, 1 coulomb, and 1 volt, and you can define volt also. So volt, the definition of volt will be same. Is it clear? Okay, now the next point is current, electric current. Now let us come to the word electric current. Now as we know, the flow of electron in a definite direction constitute electric current. Now what is electric current? The rate of flow of charge in a circuit is known as electric current. Circuit means a path in which the current flows. The path in which current flows is known as the circuit. So therefore, current equals to, from the definition, the rate of flow of charge. The rate of flow of charge means Q divided by T. The rate of flow of charge in a circuit. Rate of flow means the time at this charge. That means the flow of electrons. The electron flows from negative to positive. Okay, while flowing electron. Okay, in what time the electrons will flow from one conductor towards the other conductor. So that indicates the electric current. That gives the electric current. So therefore, we can say electric current is the rate of flow of charge in a circuit. So it is given by I equals to Q divided by T. Is it clear? And the SI unit of current is ampere. SI unit of current is ampere. SI unit of charge, you know, that's coulomb. SI unit of time is second. So I'll write here 1 ampere, 1 coulomb, 1 second. So define amperes. Okay. Now what is ampere? Means when 1 coulomb of charge flows through a conductor in 1 second, the current flowing through it is 1 ampere. Okay. When 1 coulomb of charge flows through a conductor in 1 second, the current flowing through it is 1 ampere. So therefore we can define ampere from the relation of current. So this is also very important. I you can find current, you can find it by using the relation I equals to Q divided by T. Q is the charge which is considered as coulomb, as well as S is the time which is considered as seconds. Thank you.